assignment that's there. Today, I want to try to go through some percent composition and empirical formula. There are things that are going to come up. Well, percent composition is relatively straightforward. It's percent. Empirical formula is just going in the opposite direction. Tomorrow I've got meetings at school. Next week I'm going to leave them scheduled and we'll try to talk about the gas laws quickly, which I'll put the stuff up for chapter 14. It's really only like 5 or 6 pages. And that'll, unless there's more, no. And that'll be that. The last assignment is up. Percent composition, percents. Is part over a whole. So there's two types of percent compositions. There's one where you're given the two masses of everything, and there's one where you're given a formula and are asked to do a percent composition. So find the mass of each component, divide by the total mass, times 100. So 29 and 4.3 is 33.3 grams in total. So if I want to find percent silver, 29 grams of silver over grams total. Whether you write the times 100 or not is somewhat irrelevant. 29 divided by 33.3 gives us 87% of that compound is silver. Percent of sulfur is 4.3 grams over. Now, I always do the math out just because I'm a nerd and like to play with a calculator. If 87% is silver, the other one should be 12.9. 4.3 divided by 33.3 is 12.9. So that's one way to do it. You're given the mass of two things. The only way this type of question can get complicated is if I could say 33.3 grams of a compound containing silver and sulfur are analyzed. 29 is silver. The rest is sulfur. Find the percent composition of both. You have to do the subtraction in the opposite sense. The more common way to do a percent composition is from a formula. We assume we have 1 mole. If we have a mole, can we find the molar mass? So in this case, it's 2. Carbon is 2 times 12.01 grams is hydrogen. There's 4 times 1.01 grams. I do this way for a specific reason now. So this is 28.06 grams. If we have a mole, I don't know why I put an H in there. We therefore have 24 grams of carbon, 4 grams of hydrogen, and 28 grams of this is ethylene. So we know the mass of carbon is 22 grams of carbon. We have total. So we're just finding the molar mass and doing the pieces. 85.6 64 grams of hydrogen over, and this should be 14.4. 14.4. Oh. And if you're making new organic compounds, this is something that is still done to this day. You send something away and they do an elemental analysis, which is a percent composition. So you figure out what your percentages should be. They go, you send it away, they burn it and do all sorts of fun analytical chemistry and come back and say, well, if your percents are exactly right, you have it. If not, well, you've got some work to do. Complicating matters, and there's some questions down there that you can potentially do. Percent composition of aluminum carbonate. Aluminum is +3. Carbonate is -2. So we have the formula Al2. So we have 2 aluminum. We have 3 carbon, and we have 9 oxygen. And we have, that's 16. So 4 is 64, 8 is 128, 128, 138, 144 grams of oxygen. This is 36.01. Oh, I gotta do this. It's not 0.01, it's 0.03. Oh, I can't do that in my head 2 times. I can, but 53.96. 9, 9, 13, carry the 1, 6, 10, 13, carry the 1. Grams aluminum, grams carbon, grams oxygen. So now we can go through and find the percent of each. I'm just writing them all out so I only have to. %23 aluminum. And 2038.5. You could figure it out. 61% oxygen. So find the molar mass, and if you do it piecewise with in steps like we did way back, um, you can. You have everything. If you just do all of that in the calculator, you get this number. Because I could do my molar, wow, that was 2 times 26.98 plus 3 times 30. I can do that all at 2 times Okay, I don't know how I got that other number that was there. I must have typed something wrong. Um, but we can do it all out in the calculator. You can do it all at once. If you do it this way, you have all three. You have to do both parts as it is. Um, those are some questions on this and percent composition. So we have empirical formula. Empirical formula is a whole number ratio of elements in a compound. It's not what we deal with a lot. The molecular formula is the actual number. So C12, or let's do C6H06 is an example. That's a molecular formula because it tells the actual ratio, 6 to 12 to 6. But is there, in math sense, a common factor there? Well, yeah, there's 6. So the whole number ratio is C1H2O1. That's the ratio in which they occur. CH2 is a, whoops, empirical formula, it's the smallest. A particular molecular formula that could have that same formula. Empirical formula is the smallest ratio. That's C2H4, C3H6 are both molecular formulas because they're actual ratios. Um, Sometimes, like in water, it's both. So to find the lowest number, well, this one we said we could divide by 6. Carbohydrates. That's the derivation of the word carbohydrate. Hydrate is another word for water. CH4N2 looks like you could, but that's a 1. So the empirical formula for that one is if you can't divide everything, it's a ratio of types of atoms, we get, so calculating an empirical formula, we have to get mass from a percent composition. If we assume we have 100 grams, if I have 33% carbon, if I have 100 grams of a sample, I have 33 grams of carbon. We turn percentage into masses, then we turn grams or masses into moles, and then we find a whole number ratio. So I've got 3 things set up here. A fairly straightforward one. Calculate the empirical formula of a compound that has 38.67% carbon, 16% hydrogen, 45% nitrogen. So we say in 100 grams, if 38.67% is carbon, we are going to have 38.67 grams of carbon. If 16% of 100 grams is hydrogen, we're going to have 16 grams of hydrogen. If 45% of that 100 grams is nitrogen, we're going to have 45.11 grams nitrogen. Well, we don't like that. We want to find in 1 mole of carbon. Well, I know I can do that calculation. So we would have 3.22 moles of carbon. I can do the same thing 16.06 1 mole of nitrogen is 14.01 grams of nitrogen. So we convert each percent as a mass into moles. So we have 3.22 moles of carbon, 16 moles of hydrogen, and 3.22 moles of nitrogen. We want to find the whole number ratio, divide by, why I didn't highlight that, I don't know. This is the kind of key step. Divide everything by the smallest number of moles, which in this case, because it's a ratio, we're going to divide that by 3.22. Divide that by 3.22. Divide that by 3.22 because they're the same. This gives us 1 carbon, 1 nitrogen, and 4.985, 4.987,577, which rounds to 5 hydrogens. So now we have our empirical formula is 1 carbon, whoops, 5 hydrogens, and 1 nitrogen. So this could be CH3N2s or a number, well, I guess that's technically. So I think I've got one more example. There's a couple questions there. It really is this straightforward. By rights, in 100 grams, we have 3 grams of hydrogen, 44 grams of carbon, we do our conversion. These are all carbon, hydrogen, nitrogen. They technically can be any compound. We do our division. 3.7 divided by 1.01 is 3.66. Three point. I really got to pick more exciting examples. Divide by, technically, well, we have 1 hydrogen. 3.7 divided by 3.66. 3.7 divided by 1.01. That's effectively 1 carbon. That's a really not all that exciting. There's questions there. It looks like there should be more stuff. because we can do something with this. If you're given the molar mass, we can calculate how many times we have to use the empirical formula. So if you're asked for a molecular formula and you're given an empirical formula and a molar mass, so we can calculate the empirical mass, 1 carbon, so calculate the mass of the empirical chunk. 5, 6, 7, 8, 4, 8, 5, 6, 7, 8, 9, 3, and now we're going to calculate a ratio. How many times do we need this to get that? So a ratio is the molar mass over the empirical mass. You have to have the molar mass to do this. 98.96 grams per mole over 49.48 grams per mole. So this gives a ratio of 2. So that means we need 2 of those units. To make the actual molecular formula. So we need, well, I would write it as 2 carbons, 4 hydrogens, and 2 chlorines. I'm going to do one more, and then there's take the percent mass. The molar mass gives you an interchange of moles. So that's the molecular formula. This is the same thing. Find the empirical formula. It's just a combination of the two. Carbon is 12. 2 hydrogens is 1 oxygen. 6, 7, 8, 9, 10. Carry the 1, 30.0. (180) divided by 3.0.0. This is, damn it. That's going to give you a ratio without calculating. 18 divided by 3 is 6. It's a ratio, so we just want our closest whole number. So we have CH2O times 6 is going to give us C6H12O6, which makes sense. If it has an empirical, the most common thing with that is a hexose. Technically, I think you can have C5H10O5, but I'm not 100% sure. So for a question like this, ibuprofen, find the empirical formula. Find the empirical mass. Find the ratio. And then and I'll put an answer up for that one. And caffeine, and there's the actual mass. And there's a couple other ones, nicotine and epinephrine or adrenaline. That has a molar mass of 180. It's not CH2O because it's carbon, hydrogen, oxygen, and nitrogen. So I'll put at some point, probably tomorrow, I'll do some of those answers up and upload them. And that's kind of empirical and percent composition in a nutshell. I know that was fast and furious, but this is all so you've seen some of these. If you want to try one of those or both of those or all four of those, um, that would be great. Tomorrow you can sleep in, stay in bed, and we'll do a couple gas laws things next week.
Can you go to the bottom of the first page that we just went over?
The very first one,
Yeah.
this one, no, that's the second one. Down here,
Yeah, I think
cold coffee. You good?
Yeah.
I know that was quick, and I'll upload those so you can kind of go through them if you want to take a look again. But that's all I've got for now. I'll see, well, Sarah and Amy in half an hour.
See you next week.
So yeah, have a good weekend.
Too.
Thank you.
See you. Bye.
Bye.